One of the things that I've always been a little worried about is trying to solve every future problem and slowing down the progress of folks that have actual business cases that can launch right now. So for example, these drone delivery operations, it's great that we can enable those without necessarily trying to solve the eVTOL to small UAS conflict problem, right? We don't need to solve that problem right now, and we can still enable these business cases.
Welcome to The Vertical Space, the podcast at the intersection of technology and flight, featuring deep dives with innovators, early adopters, and industry leaders. We are your hosts, Jim Barry from Celerity 05 and Peter Shannon and Luka Tomjanovich from Rios Capital. At Celerity 05, we believe that breakthrough air transportation capabilities come from leveraging current and emerging technologies, and that companies achieve profitability through relevant technologies, strong teams, and a deep understanding of the aviation market. Connect with global aviation experts at celerity05.com for feedback and recommendations to chart your path to success. At Rios Capital, we invest in early-stage deep tech that redefines what is possible in aerospace. We partner with founders building next-generation aerospace capabilities, from advanced design and development tools to the digital transformation of the flight environment, novel use cases and forms of flight, and the software and systems that make them possible. If this describes you, reach out. We're excited to connect. All right, let's dive in.
Hey, welcome back to The Vertical Space and a great conversation with Dr. Joey Rios, Chief Technologist for the Aviation Systems Division at NASA Ames Research Center. I think a lot of you will enjoy this conversation for a variety of reasons. You may love UAS traffic management and want to hear the foundational elements of how UAS UTM was created and how it evolved and what it is today. I found this to be such a cool part of the talk because I remember those early days of UTM. You may like to hear about the early use cases and how those may or may not have changed as the UAS and UTM matured throughout the years. Many of you will enjoy hearing about the early discussions in the creation of today's US-based Federated system and why it continues today and why it's different than other systems throughout the world. You could hear Joey's read on today's Dallas operational evaluation site. You'll hear a great discussion around how to solve for BVLOS outside of the Mode C veil. This conversation with Joey is an easy listen around some important and complicated stuff. And it's essential listening if you want to understand where we came from, where we are, and where we may be going with UAS, advanced air mobility, and UTM. By way of background, prior to his current position, Joey served as the chief engineer for the Air Traffic Management Exploration, or ATMX project, after serving in the same role for the UAS Traffic Management Project. In those roles, he helped develop the previously undefined concept of federated traffic management with help from industry and the FAA. His work generally focused on computational and data issues related to the National Airspace System. He has worked on large-scale operational models for traffic flow management, data exchange schemas for air traffic, and tools for general aviation pilots flying in remote locations. His most recent work has emphasized the importance of discovering and applying appropriate architectures to solve problems. Following 2 years teaching math in Papua New Guinea via the Peace Corps, Joey obtained his MS in computer science from Cal State Hayward, followed by a PhD in computer engineering from UC Santa Cruz. Joey, a great conversation and many thanks. And to our listeners, we hope you enjoy our talk with Dr. Joseph Rios as you profitably innovate in the vertical space. Hey, let's do something fun for a moment. I want to see how many of you are still listening to this introduction or if you've skipped to the beginning of Joey's talk. If you're listening, send me an email at jim@theverticalspace.net. Again, .net, jim@theverticalspace.net. Enjoy the talk.
This episode of the Vertical Space podcast is brought to you by Avionics. Avionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let Avionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. Avionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
Hey, Joey Rios, welcome to the Vertical Space. Great to have you join us.
Oh, thanks for inviting me. Really happy to be here.
Is there anything that very few in the industry agree with you on?
Yeah, there's something I often say when I'm in conversations with folks, and it's that building, maintaining, operating aircraft is hard, but building, maintaining, operating the airspace is harder. I often say it a little tongue in cheek, really to kind of spark conversation and thought. But I probably in my heart, I believe it, but I'm also coming from a space where I've never built an aircraft, so I'll plainly say that. I just know the airspace is complicated, it's complex. And I think what drives that is really the number of stakeholders involved and the number of kind of competing objectives of the people involved in order to make it keep doing what it's doing.
And Joey, why do people underestimate what it takes to design and maintain an airspace? Why is that a contrarian view?
I think that people just don't have a full view of everything that's involved in designing, maintaining, operating the airspace and evolving it, right, for these new entrants. I think a lot of people, one of the things I use in a lot of my talks is I talk about the thing where a bunch of folks are in a dark room feeling that elephant, right? And if you're feeling the leg, you think it's a tree. If you feel the tail, you think it's a rope. If you feel the ear, you think it's a fan. So they all have their perspective on what the thing is. But until you turn on the light and everyone sees it, right, you're going to have trouble making folks agree on what that thing is. And to me, the airspace is like that, and more specifically, UTM is like that, and I know we'll get into that. So really trying to bring together those different perspectives to create the right thing and to understand what we're trying to build and maintain is really important, and it's difficult. And I think it's a larger set of stakeholders than you have when you're designing, let's say, a single aircraft or operating a single aircraft.
Is there any one aspect that is particularly challenging that stands out?
I think it's just the inflection point we're in now, right? When we're trying to evolve from how we've always done ATC and ATM to how we think it needs to be done to accommodate the new entrants, right? At scale and safely. So I think it's that part, I think, is the challenge right now, and it's what's exciting about the space we're in.
I completely agree with you. And it seems that it's considered a given. And when we consider the risks of the deployment of some of the vehicles we're looking at right now, and you see some of them are public companies and they have to articulate the risks. Even though with the airspace, the air traffic management is considered, what do you think is a risk for whether it be drones, for some of the larger passenger carrying vehicles that they're not considering?
I think folks are all aware of the issues with interoperability, right? When you have this really heterogeneous mix of fleets and operators and operations, I think those are the risky touch points, right? Like if every vehicle was the same in the airspace, I think we could have a really slam bang ATM system would easily evolve it and make it more efficient and everyone would be happy. But the fact is we've got a heterogeneous set of vehicles and operators, and it's becoming more heterogeneous throughout time as we go forward. So I think that's the issue, is that interoperability. And that is one of the things I think would be great to talk about a bit more, is that perspective of how do we solve for everyone's needs, right? Without holding up everybody, right? So how do you kind of prioritize what those changes are? So I think folks need to really, and a lot of folks do, I'm not saying they don't, put stock into how do we make sure that these heterogeneous operators, operations, aircraft all operate safely in this airspace.
Great, Joey. This is going to be a good conversation. So give us a little bit of a history lesson. Talk a little bit about ATM, the evolution of UTM. Set the stage. Talk about what is it, what's the complexity, what are people generally misunderstanding?
Yeah, let me know if I go astray, and if I miss anything, happy to circle back around. But ATM and the importance has kind of always been there since we knew there would be multiple aircraft in the airspace. There was an incident over the Grand Canyon in I believe it was the 50s, I hope I don't get my history wrong, where two passenger aircraft collided, all lives lost. And that really kind of rang the bell for like, hey, we probably need to do better at managing this traffic, right? So that spurred change and innovation in the airspace. And we've always kind of understood that we want to stay ahead. And I'm talking we, the royal we of NASA. A lot of the airspace research in the United States happens at NASA and other facilities, and wanting to stay ahead of the current trends. So with a history of building technology and transferring it over to the FAA and publishing our thoughts about it and publishing the data about new systems and ways to manage traffic, one of our researchers, PK, at NASA, Parmal Kapartkar, he saw that everyone's talking about small drones and how they're coming. And they're going to darken the sky, right, with all these cool use cases, agriculture, infrastructure inspection, public safety. Everything's going to be done with small drones. And we thought that was great. That makes sense. As a single operator, I could imagine myself performing that single operation of inspecting infrastructure, taking photos, delivering a package, doing an agricultural survey. I can imagine all those things happening cleanly on their own. The question is, what happens when all these operators want to do all those things at the same time, all nearby each other? Can we keep the airspace as safe, at least safe it is now, and accommodate all these operations. So that was kind of the trigger, is this thought process from PK to write that down and to start bringing people together to start talking about that. And that's where UTM arose in the 2013-2014 timeframe. UTM as a term never existed before that. It was codified in an initial white paper by PK. And then after we got enough stakeholder interest and buy-in from the FAA, from operators, from OEMs, that this is probably something we should be looking at, that's when the key got to turn it into a project at NASA. So now we're in the 2014-2015 timeframe, and I served as the chief engineer for that project from the beginning, and starting to bring folks together to figure out what would this system look like, what does it need to do. And we designed and tested it through kind of a risk-based approach. We thought about it in terms of areas of operation of increasing risk. So let's start out with just line of sight operations in the middle of nowhere. Like, what kind of digital system would help manage that kind of traffic if there was any sort of density? And we moved that all the way through a set of technical capability levels, or TCLs as we called them, 1 through 4. And at TCL 4, we ended up in Corpus Christi, Texas and Reno, Nevada, testing these in a pretty urban environment with multiple operators, multiple service providers. So that was a quick evolution through 4 or 5 years, from TRL 1 through essentially 7 or 8, right? Depending on how you look at it, through TRL 7, let's say. And now, if you look at what's happening, I think we're at TRL 9, I would argue. It's not NASA technology that's TRL 9, but they're operating in an environment in the airspace using UTM services throughout the world, but specifically focused in the US and Dallas. So that's a quick highlight from the Grand Canyon through Dallas, Texas this year. And there's a lot of places we could go in between if we want to circle back.
So let's say we're back in 2014. And I think I was at Moffett Field in some of these initial industry discussions. And let's say you had a whiteboard up on your wall and you're mapping out the future of UTM, near term, long term. What were the things on the left side that says we got to avoid these things? And on the right side, it has to be able to do the following.
Everyone kind of agreed at the beginning that the solution would not be, let's figure out how to have air traffic controllers help manage this stuff. So that was kind of off. Everyone kind of understood, hey, we can't, if there's any scale to these operations, you can't just double, triple, quintuple the amount of traffic that air traffic controllers have to care about, right? Especially when they're much lower risk operations in lower risk environments. We don't need those controllers. So how do we start to automate this process? How do we start to focus more on digital exchanges, things we didn't have to think about so much at the beginning of ATM when a lot of these systems got nailed down? How do we focus on the machine-to-machine communication to allow safe operations in the airspace? So that really was at the forefront when we started thinking about it. And from there, it was like, what are the use cases? Let's walk through it. If you're performing a survey here and I want to perform a package delivery that goes across there, what would happen? What do we expect to happen? Should nothing happen? Should the vehicles be fully equipped to just avoid each other and we don't need anything? Should we require you guys to share positions with each other? Do we just share phone numbers with each other and you guys call it? Can this scale? Can this not scale? Really going through that discussion with people at the table that had skin in the game, folks that were building vehicles, building businesses, and folks that had to regulate this ultimately in the end. And that's how UTM evolved. This wasn't a NASA only activity ever from the beginning. It was a NASA idea, but immediately we had to bring in the right stakeholders to the table to make sure that we were building the right system.
And as you were going through some of these initial questions and assumptions, what lessons did you draw from traditional air traffic management, and where do you see that those similarities ended?
Yeah, it's a good question, because at NASA Ames and within NASA more generally, actually, there's literally centuries of experience in air traffic management, right? In building these systems and testing them out and transferring them over to the field. So that we had all of that to pull upon, which is great. We just knew that, again, with that initial assumption that we're not going to have air traffic controllers managing the system. So how does it work differently? But what are the features we still need? How do we achieve the safety that we're targeting? How do we codify what we're doing? One of the things that drove us were these 5 principles that we had. One was that we just make sure that, hey, how do we help folks make sure drones don't hit each other? How do we make sure drones don't interact with traditional aviation? How do we give some sense of priority or access to public safety operations? And how do we make sure that everyone has a common view of the airspace? I think I only listed 4, but these were the kind of things that were guiding us forward in terms of aspects of the system we were looking for. So again, we knew that there probably wouldn't be a centralized authority that could manage all of these effectively. We would have to leverage the operators themselves to help manage the airspace. And this is where that idea of federation starts coming in. The simplest thing for us, honestly, would have been, hey, here's a centralized system. Folks, just send in your data and we'll say yes or no, and you guys are going to be good to fly or not fly. That's an option. And that was on the table early on, as we had kind of a quad chart that talked about how federated something should be versus what are the business cases. And folks weren't into that, right? They didn't want some authority to tell them yes or no with this godlike voice when they knew that they could fly safely.
I'm curious to learn more about what drove your thinking. What are the factors that you have considered and how you ultimately got to the place where you are at right now?
Yeah, thinking about the Federation first, like where that came from, it really had to do with decomposing the system into those roles and responsibilities. There's responsibilities first, thinking about a functional decomposition. What are the actual things that have to happen? What are the functions that are going to occur in this system? And then building an architecture that did not prune off any real business cases right at the beginning. That was actually a major concern of ours and something we talked about quite often. We could start going in this direction right now, but if we do that, that limits potential business cases down the road. So we tried to keep that aperture as open as we could from the beginning. And I think that's what allowed this federated architecture to evolve and come to be. So, for example, if again we decided we wanted this one godlike system that everyone just submitted their data to and it let everyone know what they needed to know, that's actually pretty easy, and we can go to one big OEM and they would go build it based on the requirements we all came up with. But again, did that limit the ability of the system to evolve? Did that cut off the ability for other folks to innovate in this space and to enter this space? So that's what actually kind of drove a lot of the Federation. That and folks wanting control and kind of more certainty in their operations. We hear that from traditional operators all the time. They actually may prefer extra delay if there's certainty involved, as opposed to being told maybe you can go. And these small UAS operators were kind of the same way, right? They really just wanted to know when they could operate, not operate, how much flexibility they would be able to maintain with their operations. And this federated architecture really allowed for that. And that's what kind of drove that innovative idea of how we'd manage the airspace, empowering the operators to help us manage it through this federated approach.
So the federated, frankly, sounds very American to me. Don't give me a centralized person. We'll operate as cowboys as much as we possibly can, which is part of our tradition. What would you have done different? I mean, not a lot of people have followed the federated model.
I don't want to make it sound too full of ourselves, but I like how we did it. I like where we came out. I think we did a pretty good job given the time and resources we had. And I think it's telling that the approach that we really outlined and were the first ones to test allowed for folks to modify it and tailor it to their airspace and their needs, right? You'll see something slightly different in Europe, even in different states within Europe. You'll see something slightly different in Australia, something slightly different in Singapore, something slightly different in Japan. And I think that's good. And that came from our, again, not trying to prune too much off at the beginning. If we'd come up with one solution that wasn't flexible in that way, that probably would have made adoption of the idea and concept of UTM very difficult around the world. And you probably have a bunch of different things that are too different to allow folks to innovate across borders. So I'm actually pretty happy with the way we did it. I don't know if there's one thing I would go back and change. I think it went the right way. And it also laid the groundwork for how NASA does a lot of work now. This ability to bring in and this notion that we need to bring stakeholders in early and often, especially when new entrants are involved. We need to have as broad of a coalition as we can get to make sure all those stakeholders are at the table, to make sure we get the right requirements, that we're designing the right system. So I do feel like we made some good choices as a team and came out pretty good in the end.
So Joey, if you look at the UTM implementation and the operations with some of the drone operators in the Dallas-Fort Worth area recently, what's your assessment of how UTM is implemented there and how different is it from the original vision for it?
I think it's very in line with the original vision. I think that we honed those requirements and defined those services better along the way, and that was the point of the research. If you try and compare it to like exactly what we wrote down 8 years ago, yeah, there's going to be deltas, but the system and the approach allowed us to evolve to where we are now. So I like what they're doing in Dallas. I love it. NASA's at the table as an observer and as an advisor in that area, along with the FAA. The FAA obviously has a different role since they are the regulator, but we're there as kind of just technical advisors at the table at their committee meetings and talking with the FAA to help shape what we need to get out of Dallas in order to make it effective and scalable. So I really like what they're doing. I like how they have focused on the minimum set of services that are necessary to start to enable operations. And I think that's vital. If you try and implement everything that we ever conceived all at once, first of all, that doesn't add value right? You're not actually adding any safety to the system at the current density to consider all of those concepts and all of those services. But to really focus on that initial service that helps unlock BVLOS operations, I think is great, right? And I think we're learning a lot. And that's one of the things I'd like to try and get across quite often when I talk to folks is that solving these problems for small UAS are actually helping us learn a lot about how all new entrants are going to be entering the airspace. And it's not about the fact that they're going to use the exact same services that small UAS use. It's that the FAA is learning, how do I recognize these services? How do I define a service provider? How do I need to certify a service provider? And how would I do that? These kind of questions are being answered currently through this activity at the test site. At the key site in Dallas. It's not a test, it's an operational evaluation. I'm going to be very clear about that. And I do like the way they're doing it. I think we're learning a lot from a lot of different perspectives for sure.
Can you describe that operation for our audience?
Yeah, so there's multiple operators. Some of them are completely vertically integrated, meaning they supply their own vehicle, they do their own operations, they provide their own services. Some of them leverage service suppliers. So they may build their own vehicle and perform their own operations, but they will actually use a separate party to provide the UTM services to help them interoperate with other operators. So we're seeing multiple service suppliers coordinating their operations using standardized UTM services that are recognized by the FAA at this point as a means of compliance to this issue of UA to UA conflict. And it's working well. InterUSS is a key part of that, right? As a separate entity under the Linux Foundation, providing testing and reference implementations of some of the software that everyone can point to and leverage. But from a simple use case perspective, if I am Wing and I'm delivering from a Walmart parking lot, I am sharing my intent with other folks that also have a service supplier that may be operating in the same area. For example, let's say it's Mana leveraging ANRA as their service supplier. So now Wing, as a service supplier for themselves, would provide their intent to ANRA, who would then share it obviously with Mana. And now Mana is aware of Wing's operations, and likewise Wing is aware of Mana's operations. And they can effectively deconflict on a strategic horizon and effectively perform all their operations. So that's being demonstrated right now at this operational evaluation in Texas. And the scale keeps growing, which is pretty exciting to see.
Joey, talk a little bit about BVLOS and what's needed to safely scale BVLOS in mixed-use airspace.
Yeah, the way we're seeing it done right now is that they are leveraging this Mode C veil and the requirement that any crewed operations in there would be equipped with ADS-B out, that the small US operators could sense and then appropriately avoid those operations. So the good news with these delivery use cases is that a lot of their business exists within Mode C veils throughout the country, which is great. So how do we expand that beyond the Mode C veil? That's still an open question, and I think there's multiple ways to do that probably. But one of the things that I've always been a little worried about is trying to solve every future problem and slowing down the progress of folks that have actual business cases that can launch right now. So for example, these drone delivery operations, it's great that we can enable those without necessarily trying to solve the eVTOL to small UAS conflict problem, right? We don't need to solve that problem right now, and we can still enable these business cases. And within the Mode C veil, the unequipped crewed operation is mitigated by staying in that Mode C veil and having folks broadcast that ADS-B out. So that's kind of where we are right now, and it's enabling a lot of different business cases, and I think that's really valuable.
Joey, staying on the operations of unmanned aircraft within Mode C veil and how they deconflict among each other, not with traditional ADS-B equipped aircraft. With the way that things are set up currently, certainly at the key site in Texas, but also elsewhere, where do you see the practical limits of this architecture, of this approach?
I think it remains to be seen where those limits might be. I do think it probably comes down to just physics and safety buffers that folks are willing to accept. So these operations, if you look at how these guys are flying, they have a lot of confidence they can stay on their route. And that's because these operations are very short duration. And I think that's one of the things that folks have trouble wrapping their mind around a lot of times, is that they think about traditional operations. They're like, okay, I'm going to take off in 2 hours, and then I'm going to fly 3 hours, and I'm going to land at this other airport. Okay, now that's a long distance and a long time horizon, and a lot of things can change in that period. Now, if I'm going to take off in 1 minute and I'm going to fly 5 minutes, and it's all within 2 miles of where I take off, I have a lot more certainty about what's happening right now. So I do think that a lot of the limits in terms of what we'd see in traditional aviation of how far you can look ahead and how certain you can be that strategic coordination is enough kind of go away when you get down to these shorter time horizons. And when you look at the trajectories that these guys are flying, they're very tight, they're very controlled, they have a lot of confidence in their aircraft. A lot of them have flown many thousands of hours in these airframes, right? So they know what they can do and they know the conditions they can fly in. It seems like a very risk-appropriate approach that they're taking. And that's a term that I've grown to love, is kind of risk-appropriate, not kind of over-constraining the system too early.
So when you say that it is still to be determined where the limits of this architecture is, what are you hinting at? What do you expect, given what you just described about the ability to have much higher level of certainty about this four-dimensional trajectory than in traditional aviation one might expect? What will give first then, as the system scales to include lots more operators or just higher volume operations?
In the NAS and in aviation generally, I don't want to say the scary stuff, but the important stuff happens in these off-nominal cases, right? When something goes wrong. So I think that's probably what constrains it more than like how much data can we push through or how certain are we that this one vehicle can stay on trajectory. It's what happens if there are a critical number of aircraft in the air and if a certain critical component fails, whether it's part of this UTM architecture, if that goes down, can the airspace stay safe? Can it recover from that? Can we get to a safe state from there? I think those are the questions that drive kind of the capacity of the system right now. It's not so much the technical architecture of the services or the DSS or authorization. Like those things can handle a wide load, right? We know how the internet works. We know how services work. They can handle a lot of data and be fine. It's really if one of these components kind of goes down, what's the effect overall? And can the system get to a safe state from that? I think the answer is probably yes, but I think a lot of those questions still need to be answered.
What elements of that system are currently in charge of doing that?
So the kind of key components in the architecture are the USS, the UAS service supplier, right? That is helping perform strategic coordination for these operators. And in order for these guys to communicate with each other, these services to communicate with each other, they need to be able to discover each other and make sure their data is synchronized. And that's what the discovery and synchronization server does, the DSS. So those are two major components, right? And remember, there could be multiple USSs, so there could be 3 or 4 of those. And there's a DSS that is also federated in itself currently in the US. And then there's an authorization server that is separate from these components that makes sure that folks are authorized to be in this network communicating with their data. So if we talk about those major components, if and when more or one of those go down, does the system stay safe? I think there's contingencies and requirements in place for it to do so. But again, I think that may be the thing that keeps a cap on things until we fully understand how the system works in operation.
Got it. And now if we think about operating outside of mode CVAL and deconflicting or integrating with traditional aviation, you said that this is also something that will be dealt with and discovered in the future. But what are your thoughts? How does operating BVLOS outside of mode C get implemented in a practical manner? Does it require electronic conspicuity as a fundamental assumption, or are there ways to work around it?
I think the e-conspicuity question is a good one, and I think it would be helpful if that was more standardized, let's say, right, and affordable. So I think e-conspicuity is an important technology, and I think that there was either, let's say, a mandate or a technically feasible way to make sure that everyone agreed that was a right way to implement it, that would be really valuable. I think in general, small UAS operators, well, I would say for certain small UAS operators want to keep the airspace safe. And I think also what we need is guidance from the regulator in terms of what are those rules of the road? What are those pairwise actions that have to take place between operations? Who avoids whom? Who has primary responsibility for doing that? I think answering those questions outside the mode veil are important. I think the idea that I've always flown this way, so I should always be able to fly this way, probably isn't the way to think about it, right? It is a shared resource. And if new entrants are coming in with real business cases and real safety cases that can be met, but it does impact others, we have to figure out how to make that happen. So yeah, e-conspicuity is something. I think surveillance of small UAS in large swaths of area, that doesn't seem feasible. I think most folks agree that's not going to be the way. So you can't just provide radar feeds of small UAS to everybody. However, you can provide electronic data of small UAS to everybody. So that could be also a solution. It is a two-way thing, right? Whether it's e-conspicuity of the small UAS and or the crewed aviation. so they can sense each other, or just data being made available about small UAS operations to traditional operators, right? A lot of them are flying even if they're not equipped with ADS-B out. A lot of folks do have ForeFlight. They do have a connection.
All cooperative planes, right? Or
Yeah,
aircraft.
yeah, exactly. So if that was the case, right, there's a lot of ways to share data as well and to remain connected in that way. And there's ways that you're not necessarily sharing that with everyone all the time, right? There's ways to protect those data, because I know privacy is one of the reasons that a lot of people aren't equipped with certain equipment, but there may be ways to share those data and keep the airspace safe.
So there's lots of options, lots of uncertainty, lots of decisions yet to be made. But what would you recommend? What would your approach look like?
Well, I think if we look long term, one of the things NASA likes to do is look as far out as possible, as far as reasonable, to stay ahead of the FAA and all the operators and the OEMs to make sure that we're trying to knock down some of the harder problems if we can along the way. Right now, that kind of sits with Sky for All within NASA. But we do think that this idea of federated services and third-party service providers is something that expands to the rest of the NAS. So like, how do we start to engage and have other operators playing nicely with everyone else in this kind of digital playground where we're all exchanging data properly? So that doesn't necessarily mean we're providing real-time tracking for everybody all the time, but maybe there is intent sharing so that we can, at least at a strategic level, hey, we know there's someone that's going to be flying here this afternoon. Let's be aware of it, right? That could be a first step. So I think having services that are interoperable amongst different types of operations is going to be important. And again, I think the idea that I've always been able to fly this way, so I should always continue to be able to fly this way might be tricky to kind of uphold in the long term. We got to all share this airspace. So how do we get there?
Just to make it a little bit more real, can you walk us through an example, a real life example of what this might look like?
Sure. If you want to take, let's say, a crop duster. The crop dusters, a lot of times, are not equipped ADS-B. They're older equipment. They haven't really had a need to have ADS-B out before. But now the crop duster may be close to a neighborhood where they're getting deliveries from Walmart now. We know a lot of agriculture and suburban areas are starting to butt up against each other quite a bit. They get closer and closer every month. So is there a way for that crop dust operator to share their intent in kind of a painless way so that the small UAS operators know when those operations may occur? And I think this question of like look ahead time and such is something we have to tackle, because traditionally, and now I'm coming at this example from public safety, just in terms of look ahead time. They think when I know I got to go, I got to go. I got to get an aircraft up in the air and I got to go do the thing I have to do for reasons of safety or security. And that's all understandable. And when they're talking about I need to go, when I know I need to go, I need to go, they're actually, in terms of a human scale, yes, that's very quick. In terms of a digital scale, that may be almost an eternity, right? So if a minute before your aircraft goes up, that's plenty of time for a lot of these delivery operators to plan around or adjust based on those data coming into the system before that public safety operation gets in the air. So getting back to that crop duster, even if they have ad hoc operations, it could be done very quickly in terms of a push button on a ForeFlight app, for example. It could be any kind of application or user interface, but that's one that's widely used. So it would be easy to share the intent of something like that so that other operators, including small UAS delivery operations nearby, would know that's going to occur. And again, that's just one example. You could also have an infrastructure inspection, right? A helicopter going over power lines for a long time, submitting that so that small UAS operators know that's going on. That's good awareness for them to have to kind of avoid that area at that time.
And just drilling down to make it more real, in the absence of the crop duster being equipped with ADS-B, how would the pilot of that aircraft share their intent? What would the load on that pilot be?
I think it really can be minimal. You could have I've never been a crop duster. I haven't talked to a lot of them personally, but I think a lot of their operations are kind of well known and contained in terms of they do a lot of repeatable operations. I think it would be easy to say, hey, I'm going to be in this area at this time and have that kind of already preloaded in a cell phone, in an application that they have probably on their hip. It could also be if they want to do it at their desk before they go outside, that's fine too. They would need to be connected, so they would need that internet connection to be able to say, here's what I'm going to be doing for the next 25 minutes. But it doesn't seem like it has to be a heavy load, especially since a lot of those plans could be preloaded and say, I'm going to be doing my plan B today. I'm going to do it between 10 and 2. And if I just hit submit, then that's it. Now, other folks are aware of that. And what are the requirements for folks to avoid that? That's another question. But at least now there's an awareness that there's a crop duster in the area at this time in this area.
And what's a good way to work around the concerns of the crop duster community about sharing information for competitive reasons, where they don't want others to see what fields they're spraying and when?
Yeah, that's a good question. And we have some of that already with the delivery operations. There, you can actually extract certain business intelligence by understanding the kind of rate of operations and where they're going. So that's a concern they're working through right now. So I think we'll learn a lot through that process right now. I think the big upside is that there are requirements for service suppliers in terms of what they share and when they share it. So I think that may be a place, the governance of the data may be a place where a lot of that can be alleviated. So for example, when and where are the data that the crop dusters shared, who gets access to it, and when do they get access to it? Again, a lot of this is machine to machine, and a lot of times humans don't always have to even see it. So is there a way to make sure that we're keeping aircraft safely separated without knowing the details of specific operations? This discovery and synchronization server that I discussed earlier, for example, doesn't store operational details about anything. It acts more like a phone book for who you have to contact about information. So there is kind of a buffer. It's not like you just send in all your data to one system and then anyone can access it from there on out. There are ways to control access to those data and to govern how it gets used. So that may be a place where it gets solved.
What's the most nonsensical approach that you have heard for solving BVLOS outside of Mode C?
I feel like assuming that every small UAS can be fully equipped to avoid every hazard is kind of a bit out there for me right now. Having the technology, the right swap C, right, the cost to get to that swap is not there that I've seen. There are solutions, technologies that work. Do they work in every case? Do they work in every airspace? I think operators want to be as unencumbered as possible. We just talked about the crop duster, right? They want to be as unencumbered as possible. We totally get that. But some level of sharing is needed when there's other aircraft in the area.
So are you alluding to systems like ACAS SXU as unreasonable to expect that will be equipped broadly among UAS systems?
I think so. So I haven't seen the technology that everyone's willing to equip right now per any sort of mandate, let's say. And a lot of that comes with cost, right? If you go to an operator like Zipline or Wing and say, look, now this is the way to solve the problem, you're going to equip with this. That has a major impact on how they do business and how they build their vehicles and how they cost things out. So is that a bigger hit than the other approach where now you're asking, again, the crop duster, the infrastructure inspection helicopter, or the public safety folks to do something extra? So something has to give somewhere in the system in order to make sure that we're all aware enough to stay away from each other. And until we have that low swap C solution that you can just plop right on top of any drone and it avoids everything magically, we probably need some level of data sharing, and UTM provides that platform to do that.
But wouldn't that magic device still require some kind of conspicuity from the other aircraft or other traffic such that it can be avoided? Or what's the discussion like in the communities that you're around in terms of this balance between conspicuity for all manned aircraft versus adoptions of other onboard systems?
So some of the solutions that you would drop onto a small UAS don't require conspicuity from other operators, right? It is possible to come up with a system that, again, under some level of confidence can avoid most things or many things in certain conditions, right? The question is, again, is that affordable for or feasible for every business case to equip? And is the technology really there? Is it really to the level that folks say it is? I think that's the question. So your original question was about what is the most far out idea for managing traffic. And to me, that is it, that every small UAS just equips and avoids everything magically without anyone else doing anything. That's probably the most extreme one that I can think of at the moment. Some level of data sharing and ground-based systems, I think, help ease the burden on all the operators.
Joey, in this system that you're describing right now that's taking place today, who's making the most money in this process? What's the most viable business of all the different players who are in this scenario you're describing?
Well, if I knew that, I probably wouldn't be sitting in this house right here. But I think that, again, I might get a little out of my depth here. But in terms of profitability and viability, I wouldn't say. Let's say I wouldn't venture a guess right now. I do think it is still early days in terms, because we don't have the regulatory framework yet to recognize services, right? So is being a service supplier in the U.S. the right thing to do? It's probably too early to say that until we get BVLOS rulemaking through. If you're looking to go cross borders, if you want to do things internationally, is there more certainty in Europe or not? I don't know. I can't say. These fully integrated operators like a Wing or a Zipline, let's say, again, I'm just using them as examples, not any reason to pull them out otherwise, but they are large operators here in the US, and they are full stack in terms of building their own vehicles and doing their own operations and providing their own services. Is that more profitable or not? I don't know. I haven't seen their books. I can't say. But there are maybe easier places to enter than others. It's probably a little harder to enter in terms as a full stack operator. I'm going to build my own vehicle, perform my own operations, and provide my own services. That may be a harder way to enter than choosing one of those, for example. And which one of those, if we just sliced it in those three ways, which one's most profitable, it might be hard to say for me right now.
Where does the industry currently draw the line of certification in terms of what data and services will require some level of certification or not? How has this line moved over the last several years as people started to run these operations? And how will that ultimately impact Jim's question about where value is accumulated in the industry?
Yeah, I think that the capital C certification question kind of comes in when risk goes up. So as the risk goes up, so if you're talking about now carrying people on board, for example, we're getting away from small UAS, I think folks are in agreement that there's a level of certification there that's necessary. If you look at the operations right now happening in Dallas that are going BVLOS, and there are multiple operators there, they're not certified in terms of the services themselves. So probably you don't need certification because they're showing they can do it without it. They're using this LOA process, using the NTAP, this near-term approval process in the FAA to learn what it might be. But I think as the level of risk goes up, as we start operating outside the Mosby Veil, as we have larger vehicles in an urban environment, obviously the certification process becomes really important. But we don't want to overburden places where it's not necessary. This goes to that risk-appropriate question. What are the risk-appropriate solutions for the operations we're seeing today? How much certification is needed? It looks like for this kind of risk environment, maybe not much, or maybe that need for certification isn't quite there.
Let's say the regulator in Brazil called up and said they want to find your advice on how to safely grow a UAS economy. What would you tell them?
I think there's a lot of benefit now trying to solve the problem than if you were trying to solve it, let's say, 6 years ago. So definitely learn from what other countries have done. You don't have to reinvent the wheel. There are processes in place for a regulator to recognize how things can be done safely. And don't try and solve every problem before you let some problems be solved. I think that's really important. Again, a lot of folks are concerned with UTM because we haven't solved the demand capacity balancing problem into vertiports. So UTM is not a thing anyone can ever use. That's a really bad perspective because obviously UTM is working for these small UAS drone operators and public safety operators in the Dallas area, showing that this can scale out likely. So don't try and solve every single problem related to new entrants right away. Figure out what the low-hanging fruit is, figure out what the biggest demand is, figure out who's asking, who's at your door right now, and who's ready to operate. Try and solve those problems. There's always the risk that you're painting yourself into a corner. So I do appreciate looking out for not pruning off solutions in the future or operations in the future with what you're doing now. But again, there's kind of a wealth of data and field trials and other regulators that have started to cross these bridges. So definitely leverage connections through ICAO and others to figure out what are the things I can do to enable operations now for the folks that are at my door ready to operate, and really try and get them through, because you're going to learn a lot as you push them through the system. I can speak to just what I've seen with the FAA. They set up the NTAP because they have no way to recognize what a service there's nothing in their system to recognize a service provider that's not them as the ANSP, right? So how do they recognize these third-party services? They're learning a lot through NTAP now that is going to inform the BVLOS rulemaking. So I would say just leverage the learned experience throughout the world and answer the early questions now, and don't try and solve every problem right off the bat.
Joey, talk a little bit about where you see some of the standout do's and don'ts from different countries and who's done things particularly well, US, Canada, Australia, Israel, Europe.
Yeah, it is interesting how all these different countries and regions have approached things slightly differently, but while at the same time taking the core of the UTM idea and moving it forward. I can say I really like what I see in Australia. And again, it's just as an external observer. I haven't been ingrained with Australia or anything, or talking directly with Air Services or anything like that. But understanding how they've taken the architecture and how they've called out FIMS specifically, right, the Flight and Information Management System, as a thing that the ANSP kind of provides through a contractor to provide certain services that allow USSs to flourish outside. And again, this aligns a bit with some of the NASA architecture, so obviously I'm biased towards that. I think it removes a lot of the complexity when you have certain services that FIMS can provide and certain things that USSs can provide, rather than saying have industry solve everything. So I do like how Australia's done that.
But that flies in the face of Federation, doesn't it?
No, it doesn't. Federation is a set of kind of individual entities trying to move towards their own business objectives, but they're doing it under the auspices of interoperability and some sort of guidance on how, and rules and regulations on how that happens. But then they can optimize their own processes under that. So the question is just where you draw the lines. One thing I've heard, I think it was Eric Mueller at Joby that said it once, the airspace is already federated, right? We're just kind of figuring out where we draw the lines in this new architecture. It's already federated, right? There's a lot of flight operators that are optimizing their own business objectives, but it's under the interoperability of the NASA as a whole. There's a lot of GA operators that are, again, they're individual entities operating their own operations, optimizing their own business practices under the rules and regulations of the NASA. So federation already occurs, but we're just now digitizing a lot of it and deciding where we can draw the lines. Australia drew the line with that FIMS and the USSs on the outside, and it seems like a good approach, to put it that way.
Let's say Brazil said, I'm thinking of mimicking and parodying the Australia approach to the FIMS with the USS on the outside. Is that something you'd advocate for them? And is this something you'd think about here in the United States going forward?
I mean, quite frankly, we at NASA, I'll just speak for myself. I've always advocated for that. I thought the FAA should provide certain things, and they agree, right? They do have a way to pull certain data out for certain authorized entities that acts kind of like a FIMS-like function for certain data, which is great. But I think providing certain aspects of UTM from the ANSP makes sense to us. Again, the line is just kind of shifted a little bit. If you look at some of the early architecture diagrams for UTM and NASA, there's that line that kind of goes down the middle that separates the ANSP from the commercial side. And on the border of that are certain functions that were kind of unclear, right? We didn't know where authorization lives or discovery lives, and it sits on this border. Some of those functions from a NASA perspective, we'd probably say, hey, that probably makes more sense on the ANSP side. But we don't define how things are going to operate in the airspace. We just provide the data and the information, and then stakeholders decide which way to go. So industry has really grabbed a hold of all the functions and said, we're going to do it well and move forward. And they're showing that they can, which is great. But again, I think it simplifies the system if certain functions would have been left on the ANSP side. So I would be supportive of someone moving forward saying, yeah, I'm going to have FIMS and I'm going to have discovery and I'm going to have authorization provided by the ANSP. All of the other services defined in ASTM, we will have the commercial operators provide that, and we'll all be one happy family.
If these services are done on the industry side, Joey, how do you think that industry players can differentiate and compete?
Yeah, this is a good question, right? Because it's a lot of this stuff feels like plumbing, and it's hard to make a lot of money. Well, I guess plumbers make a lot of money here, probably in the US, but in some of these like just commodity services in a sense, right? Like the standard is defined, you're going to exchange the data under these requirements, and that's how it's going to work. And if you meet the spec, then essentially everyone's the same if they're meeting the spec. To me, I haven't built one of these businesses, but it does seem like the value add services that you add on top. Hey, if you use us as a USS to do strategic coordination, you'll also have access to all these other cool things that we do, whether it's, I don't know, tracking your pilot's hours or optimizing your routes or keeping your maintenance logs or whatever these value-added services are. I feel like is probably the way you start to differentiate. But again, I haven't built one of these businesses personally, but I totally agree that if you're meeting the standard, you're meeting the standard. So how well do you work with those folks? How much does it cost? It seems like those costs would have to come down and you'd start to pay for what else they provide you after you're kind of built into their system.
So we went deep into Australia. Are there any do's and don'ts that you want to call out from different parts of the world?
I don't know if I'd call out any don'ts here on the podcast, but I think there is value in how Europe did it, right? Getting the regulations out first. And I think that was important for them, given the number of states they have and how they have to be coordinated. Kind of that more top-down approach makes sense. So I think that kind of goes, again, back to if a new regulator came forward and said, hey, how are we going to start to enable these operations, or new NASP wants to offer these services, how would we do it? It really depends on how you guys are set up, right? And who else you have to integrate with. In Europe, it made sense that they came up with the USpace and the way it's going to go forward. But the US held back because, again, they are the regulator and the ANSP, and they could collect some data and they can enable what they want to enable when they want to enable it. So that made sense here. So I do like how Europe went about it, getting those regulations out. I think we saw one of the service suppliers, the first recognized one, right? The first USSP was announced last week, which is really exciting to see. So that's moving forward, which is great to see. So that's another good one. Japan's done good stuff in terms of how they've tested public safety crewed operations with commercial unmanned operations, which is great to see, right? So it's important testing. NASA has participated in that. So again, I'm a little biased, but just kind of seeing that firsthand has been good. So they've dived deep into that side, which is good to see. Those are a few that popped to mind off the top. The good news is that folks all kind of see UTM as the enabler, right? And they're just approaching it slightly differently in each place. But UTM at its core is about how do we enable operators? How do we go digital first? How do we kind of roll out these services? How do we break things down into services? Everyone's kind of looking at it from that perspective, which is good to see.
To say the least, there's an awful lot of conversation around modernizing the air traffic system. How would, let's say we did split off the air traffic system to a privatized model, how would it affect UTM here in the U.S.?
I think that UTM's in a good space in terms of already leveraging industry to provide services where they weren't provided before, right? So I think that UTM would be in a good space to continue to do that because, again, in a lot of ways, it's already privatized, right? There's the service providers are commercial entities, whether they are the operators themselves or they're a third party. So I think that model could still stand with the rest of the NAS moving towards a prioritization scheme. Now, I'm not weighing in on if that's a good or a bad idea, but it seems like UTM would be insulated from those kind of changes, in my view.
Where do we go from here with UTM? Next year, 5 years, 10 years? If we were going to look at the NASA whiteboard, what would be on it?
I think, first of all, for small UAS, we're more in a support role now, honestly. We're just trying to help answer technical questions that arise and provide input to the small UAS operators where necessary and to the FAA where necessary and wanted. I think it really is about how do we expand the concept of UTM to encompass more traffic moving forward. One of the things folks get nervous about is there's a lot of autonomy that can be built into UTM right now because it's machine to machine, it's digital first. So you can do a lot in terms of analyzing those data and acting on those data. So a lot of folks get nervous that, hey, is that looking to just replace ATC as we know it or replace ATM as we know it? I don't think we think so. I think we think it enables current humans in the system that are controlling traffic at a very safe level to do more with the new entrants without harming the safety of the NAS. So all these tools and this digitalization, I think, is how do we enable folks to do more with the tools that we're going to be building out? And how do we, again, continue to define services that will enable operations like air taxis or regional air mobility, those operations that won't have a pilot but will have people on board. How does this idea of ground-based services fit into those paradigms? And again, we're learning a lot in the small UAS world that is going to inform that. High altitude operations, hopefully we'll start to see them leverage UTM concepts to do safe operations up at that level where services are not provided currently, as maybe diversity increases up there. So I'm hoping to start to see the evolution of that. Again, NASA is trying to look at that, and this is where I think Sky for All fits in most urgently, looking for how do we evolve where we are now with UTM to get to a more integrated kind of airspace where services are digital first and fully integrated with each other.
Let's talk a little bit about the use cases from 2014 when everybody was gathered at Moffett Field and saying, this is where I see the next 10 years going to be. What were they envisioning back then, and how did it change from what they were envisioning?
Yeah, it's interesting because a lot of folks already knew they could fly safely on their own. So I think they would say, hey, you know what? I can already fly beyond visual line of sight under a waiver, and I can take pictures, and it's all safe, and I can come back. I don't need a UTM. So I think the use cases are really the same. We were talking about agriculture, we're talking about package delivery, we're talking about public safety. It's all the same kind of use cases. We knew what small drones could do. They may be doing it better, faster, safer now, but the ideas were all there the same. I think that what's changed since then is bringing folks along to understand, hey, you're not going to be the only one in the airspace. As these operations increase, you're more likely to be near someone who's also doing operations, even though that's not the case right now. And it's, I think, changing the mind state of folks to understand that this is a shared airspace. In order to make it work properly, we're going to have to figure out some way to share data with each other to keep it safe. So I think that's the biggest change is folks not thinking in terms of waivers and me operating in my bubble and I'm going to be fine, so I don't need all this other stuff, to how do we enable everyone to access this airspace in a shared way and not have to go through a waiver process in the long term, right? To just know what the rules are to operate and we're able to do it. So I think that's the biggest change is bringing folks along to understand that this system is necessary and it's not supposed to be a hurdle. It really is an enabler. So UTM is supposed to enable these operations at scale and with regularity and with the proper level of safety. It's not something that's supposed to be combating your workflow. It's something that's supposed to enable you to do more operations at scale.
What would you say is the biggest vulnerability in the way that UTM is architected right now, either technically, operationally, business-wise, or otherwise?
I think because there's a lot of different perspectives on it, I do think it's that interoperability between these different new entrance models. Like if there's going to be certain services for, again, demand capacity balancing for air taxis, what do they need to interoperate with small UAS? What if small UAS are now delivering to high rises in a city or something? I don't know. How do you make sure that the right data are exchanged and who has priority? So I think that's the tricky part, is when you have more than one new entrant in the same area, how do we prioritize who's doing what? How do we know which data are exchanged? Because with air taxi routes, if they're flying in regularity, that's by definition probably going to cut off all the small UAS operations in a certain bubble around there. So how do you manage this, and how do you bring folks along to know that this is the right solution? That's probably the tricky part. I think we know we can build services that do things like demand capacity balancing, that do vertiport management, that do whatever it is, corridor management, or whatever it might be in the future. But how do you make sure that's not a solution in and of itself that interrupts solutions for, again, small UAS operators or eVTOLs that need to get to altitude? How do we make sure that those kind of conflicts are reasonably handled for all operators?
Separation is central to solving some of these questions. I don't know if we can at least probe this topic at a high level, but it'd be great if you could share your thoughts on how the community is thinking about separation.
Yeah, I do think that the community still is in a lot of bubbles right now. The small UAS folks are really not trying to spend energy thinking about eVTOLs because they're trying to solve their own problems. And eVTOLs are trying to say, hey, if we're all eVTOLs here, what are we going to do? So I do think it's important to kind of discuss these things. What's interesting is that NASA works with DoD on a lot of these concepts. And we've published a couple of reports. This is kind of public information. We've had 3 flight trials with them, and they've been kind of testing out UTM and how it should work and how they want to implement it and what they need to see in their COP, their Common Operating Picture. And one of the things we did last year, or maybe a year and a half now, was they wanted to see the interoperability of all these different domains. They wanted to see small UAS, air taxis, and high E traffic management kind of working together in a unified system. What does that look like? So I think that we're going to continue to see more of that. And really what it looks like is data exchanges are important, and making sure we understand the protocols for when and how to exchange those data. And then how you interpret it with the human in the loop in front is something that can be decided, right? What is the protocol for the human? What is the role of the human in managing this traffic and visualizing this traffic? So we started to see some ground being broken with the DoD at least. And we know that's probably something that's going to transfer over to the civil side as we think about multiple new entrants in the same area trying to figure this out. I do think it comes down to data exchange. Like, when does a small UAS have to know about an eVTOL operation? The data are available. When do they share it? Do they share it with a single DSS? Are there multiple DSSs that have to be interoperable with each other? These are architectural questions that have a lot of impact. And again, if you make the wrong one too early, you're going to prune off certain business cases and you may paint yourself into a corner. So it's really important to kind of think through them and get buy-in from all the stakeholders. So I do think that there's a lot of work in this direction already, which is exciting to see. And I think that folks are going to be willing, especially the new entrants, are going to be willing to talk them through with each other because they're all kind of innovative spirit. They know they all want to get in the airspace. It's kind of a rising tides, all boats kind of thing. And I think we're going to get to a good spot as long as all these folks stay at the table and keep moving that direction.
Given how quickly drones are saturating military airspace, and given what you just said about the conversation between NASA and DoD, are there any specific things that you would perhaps call out in terms of how the DoD is thinking about integrating small UAS into their bigger air picture?
I think just the most important thing that they've done to approach it, and again, we have reports on this that folks can find online, is that you want to make sure you have, to the people that have to interface with the system, whether it's an air traffic controller or whether it's a ground operator of some kind, you want to make sure they have access to the right data to make the right decisions at the right time. So that's what the DoD cares about, is having that common operating picture that truly is common. It truly has the data it needs to give the person the information they need to make the right decisions. So I think that's the biggest thing, is making sure that all of these operators in the civil airspace that are going to be operating in vicinity of each other have access to the right data they need in order to make the right decisions.
And how are they solving for their equivalent of conspicuity?
That I don't think I would comment on. I think the test we did with them was really about UTM services. It didn't necessarily touch on what vehicles were equipped with as they flew. So with UTM, it comes down to the operator sharing data, and that can include sharing position data. So the e-conspicuity just comes from the operator kind of willingly collaborating in a digital manner, more so than necessarily broadcasting positions. Some of them were ADS-B equipped, I think, but it was just a test in the US that we were looking at.
All right, Joey, I'm a 23-year-old kid, just graduated from college, and I want to completely devote my life to the advancement of UAS integration. I want to make a big difference. Where would you steer them? Where could they have the greatest impact? The FAA, NASA, industry, and then where within industry if it's industry?
It's a good question. I do think it's on the industry side. I don't think I wouldn't turn someone away from a NASA career if they were looking for it. I think it's a great place to work and think and be around a lot of great people to kind of solve a lot of hard problems. But if you want to make a big impact right away, it is trying to find that disruption in the space where you can. There's a lot of places right now where you can have an idea, it feels like, and be successful. I'm trying to think if it would be like, would I recommend someone to be like a service supplier or a full stack thing? I think the full stack thing makes sense and it's exciting. And then you start to figure out what is not necessary for you to worry about and see where you can outsource that. Like trying to do that functional decomposition as you go is important. So what would you provide, right? What is that service you provide? Is it delivery in a specific segment? Is it medical stuff? Is it commercial delivery to homes? Or is it something more exciting? I don't know. Maybe something to do with pets, right? Who knows if that can take off. But it feels like trying to figure out a business case in this space is interesting and the technology is advancing.
Let's say they want to say, I want to focus on the hardest problem. I want to focus on the hardest problem that has to be solved that would open up the market. What would be the 2 or 3 hardest problems to solve?
See, now that pushes me over to like the FAA side now, if you want to solve those problems, right? The regulations and how the airspace is managed, an individual person on the industry side is not going to affect all that directly. So you'd kind of have to rise up the ranks on the FAA side and makes a lot of that. To me, that's the hardest problem is kind of this policy, protocols, and kind of regulations around this space that are hard to solve. Otherwise, I do think it might be, we talked on it a little bit, I think it's this kind of cross-domain interoperability. We've kind of understand what the interoperability is between small UAS. We're starting to figure out what the interoperability is between air taxis, eVTOLs, regional air mobility. We kind of understand what things are going to look like at high altitude, right? Starting to nail that down. But again, I think having all these new entrants start to merge into a common approach to separation and data sharing is a hard problem to solve. And I think it's going to be exciting to see it evolve.
And it's more likely to be on the regulatory side where it's going to get fixed.
Yeah, that's where a lot of the hard things I think happen. Technology is hard, it's difficult. Things you work on things, they work, they don't work. But then when you get to kind of the policy and how you manage the whole thing, I feel like things get really hard up there.
All right, so Joey Rios spent a lot of time at NASA and you're looking to your future. How did you map out your next step in your career?
That's a good question. I kind of fell in love with this space. I love the problems that present themselves here for new entrants, whether they're small or larger. So trying to stay in this space, I think, is important to me because I think there's more things to solve. There's more ways to kind of enable the future. We all think about the Jetsons. We all think about pizzas being delivered to our house and all kinds of things with autonomous vehicles. So I think there's a lot more here to do, and I'm excited to kind of continue impacting it.
How did you break down the choices of where to go to next?
There's a lot of companies in this space. I think I mentioned earlier in the podcast, I've never built a vehicle myself. So I think the folks that are building vehicles, trying to figure out supply chain issues, all of that stuff's important, but that's not necessarily in my wheelhouse. So I was focused more on the digital side, like how do we enable things with services? How do we start to standardize that? How do we enable these operations? Again, kind of making the airspace ready when all of these operators are ready to join it and it's not a roadblock. So how do we unlock things with these services, knowing what we know about what the FAA is learning, what we're learning in Dallas? How do we help all of this keep moving forward? So I was looking to kind of continue in that vein.
And Joey, a lot of entrepreneurs on the line, a lot of people who already have gained a lot from the answers you've provided. Any other advice to the entrepreneurs out there, given your deep background with NASA? You've seen an awful lot of companies. What advice would you give them on focus on these few things and you're more likely to be successful, even with working with NASA? What are the couple of tips you'd give them?
I think it is important to, again, make sure that you're not stopping progress on one thing because you haven't solved the problems everywhere. And again, I've heard this from people where they're worried about VTOL to small UAS conflicts. So that makes them suspect about how UTM works as a whole. So I want to say you don't have to solve that problem today. There's not a high volume of eVTOL traffic that small UAS are worried about avoiding as they deliver packages to folks. So solve the problems that are in front of you, but have an eye towards the future. And having your foot in the future may be collaborating with NASA, going to the FAA where necessary, involving yourself in standards. That's how you keep your eye on the future, but continue working on those current problems that you need to solve in order to unlock something. And we've always tried to maintain that balance where we're, okay, let's actually figure out what is that exact data schema, what's that protocol for this exact service that we're worried about, but also thinking about that architecture for the long term. So don't block yourself on the hard problems in the future. Really unlock those current problems that you know you can solve and kind of move forward from there.
And before we wrap it up, who in the government or the industry are standouts you've seen over the last 10 plus years that you would like to call out for the audience?
Yeah, there are a lot. So first and foremost, we all have to thank PK for kind of developing that initial concept for UTM. And we had a great team working on UTM on the NASA side. And I feel bad listing names because I know I'm going to forget some, but Marcus Johnson, Jeff Homola, Jae-Woo Young, we were all kind of quote unquote managers for UTM as we move forward. Ron Johnson was there as our project manager for some time. There's a lot of folks on the NASA side that really made this happen, and it was great to work there. On the industry side or the FAA side, let's say, we've worked hand in hand with a lot of folks. Initially, it was on like the next gen team, because that's where a lot of the new concepts go. Initially, we worked closely with them. But from there, we did expand out, right, to the different lines of business on the FAA side to help make sure UTM stuck and they knew kind of what our research looked like so they can start to make decisions from there. So folks over there that were great to work with, obviously, let's say Jarrett Laro was great to work with, Brandon Lint. A lot of folks have come over there from the next gen side. Steve Bradford's always been a good proponent of UTM, which is great to see. Together with the NASA management. I know on your podcast you had Bob Pierce in the past. He's been very supportive of UTM. What's really cool is a lot of the previous UTM administrators were always very interested and excited about UTM, which was great to see. So I remember Jim Bridenstine, previous, I think, Trump appointee for NASA. He was always really excited about UTM as a pilot, right, and someone trying to move things forward. Jae-Won Shin works at Hyundai now, but he was very supportive of UTM in the early days. On the industry side, there's a lot of great folks. We worked really closely with Wing, and a lot of times that was Ronaldo Negron, working closely with him. He's their UTM lead over there. He does a lot of other things as well. And now Peter Sachs works over at Zipline. He's been driving a lot of things forward, originally with the FA side and now with Zipline. So that's been great to see. There's a lot of folks. And again, I'm probably leaving a lot of folks off the list, but those are some names that come to mind. Praveen Raju works at Wing now, but he was previously at the FAA. He was always a big proponent and supporter from the next gen side on the FAA side. So anyway, I'll stop there. There's a lot of folks I could list. I'm sure you'll have to prune that list, but it's been a great ride.
That was great. That was terrific. It first sounded like you were accepting the Academy Award where you didn't want to leave anybody out.
I know. It felt like that. So I thank you.
Guys, anything else you want to ask? Joey, this has been great. Is there anything else you'd like to leave with the audience? I will say this. Let me try myself. A common theme has been focus on what you can get done. Don't worry as much about what you can't do. Is that a Joey Rios foundational statement?
I think so, yeah. And I think as a chief engineer on a project over there, we're not going to solve everything. We have a budget. We have a timeline. We're going to fix what we can with that budget and that timeline. And then we're going to have to transition that technology over to the FAA side and the industry side and support them on the ride from there. And that's always what we've tried to do from the NASA side. So that is something that's important, I think, is you can keep thinking about the future, but if you're not solving the problem right now, then, the future is always going to be there, right? So let's solve something right now.
That's great. Joey Rios, thanks so much for joining us.
I appreciate it. Thank you guys for having me.
Thanks, Joey. All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.